Sorry.
Okay, I got a couple questions for solving for reactant solution. I did one of these in class yesterday, so I'd like to do another one now. One way the U.S. EPA tests for chloride contaminants, I'm reading this right here, test for chloride contaminants in water is by titrating a sample of silver nitrate solution. Any chloride ions in solution will combine with the silver cations to produce a bright white silver chloride precipitate. Oops, lost it. Right, timed out. Fortunately, I had saved it over here. So that first paragraph I didn't copy and put over here, but the rest of it I did. Suppose an EPA chemist, this is the same problem. Suppose an EPA chemist tested 250 ml groundwater, or a sample of groundwater known to be contaminated with nickel 2 chloride, which would react with silver nitrate solution like this, blank, okay? All right, so the chemists add 29 millimolar silver nitrate solution. All right, so immediately what I'm gonna do is I'm gonna start making notes, right? There's just too much here. I'm gonna start making notes, and after I've made my notes, I'm gonna try to identify what it is I'm really looking for. So I have a 250 ml sample of groundwater, and we know that the groundwater's got this contaminant in it, contaminated with nickel 2 chloride, okay? So volume of my solution is 0.250 liters, right? And you know why I'm doing that to liters right away. I'm gonna put everything in terms of moles and liters, and so molar comes immediately out, or I can use molar mass to get moles from grams or whatever, okay? So now the chemist adds 29 millimolar silver nitrate solution. That's silver nitrates right here. So I'm going to use this as my heading for my table, okay? And this will be column 1, right? You've seen these columns before, okay? This is here's my silver nitrate, right? Silver nitrate, and I see, and I'm going to put my row heading here. It's 29 millimolar, so I'm going to put 29 times 10 to the minus 3. That way I can not put molar over here, right? 29 times 10 to the minus 3 is 2 sig figs. Silver nitrate solution to the sample. Now, yeah. Then she washes, dries, and weighs the precipitate. She finds that she gets 6.1 milligrams of silver chloride, and that's in this table, right? So our mass of silver chloride is what? 6.1 times 10 to the minus 3, right? Now, first thing I'm going to do is I'm going to find how many moles of this are. When I have a stoichiometry problem, I'm virtually always doing moles of A to moles of B game. This is always a moles to moles game, right? So let's go back to red, and let's put our molar mass, which I'm going to write as formula weight of silver chloride. The formula weight of silver chloride, I don't have I do. I have a periodic table here. My periodic table is here. Silver, let me blow this up a little bit. Silver is 107.87. And chloride is 35.45. Is equal to, let me do that in my calculator here, 107.87 plus 35.45 is equal to 143.32. And that's grams per mole, right? But I'm not going to put the units in here because I'm being very careful to be consistent. 143.32 grams per mole. And that's going to give me my moles now. Right, so my moles of silver chloride is going to equal my right? Let's come over here and do this black. This was 6.1 times 10 to the minus 3 grams, right? And it was 143.32 grams per mole. And so that's going to give me what here? How many moles is that? Times 6.1 times 3. Sorry for the background noise here. I've got, I'm doing this work in my kitchen. 1, 2, 3, 4, 5. And so I am going to be, I've got some co-workers around here. 4.256 times 10 to the 1, 2, 3, 4, 5 times 10 to the minus 5. That's how many moles I've got of that, right? Okay. Now, I haven't even started thinking yet, right? All I've done is just interpret. Now I'm ready. I interpreted this number here, right? And I interpreted that number there. And I went moles to moles because I knew I'm always going to be doing moles to gains, right? So I got my moles of that. Now I'm ready to find out what the question is. Calculate the concentration of nickel 2 chloride contaminant. Calculate the concentration of nickel 2 chloride contaminant. So I think what I'm going to do, let me go to a different page here. Let me go here. Nickel 2 chloride. The concentration of nickel 2 chloride contaminant. I'm going to go to a different color, can I? And these are typically in grams per liter, right? That's grams of nickel 2 chloride per liter of solution, right? It says calculate the concentration of nickel 2 chloride in the original groundwater sample. And I knew that there was 250 mils in my original groundwater sample. So all I've got to do is find the mass of nickel 2 chloride and I'm done, right? Mass of nickel 2 chloride is going to be there. You see that? Nickel, it'll be grams, that'll be the mass per liter and I'll be done. So that's going to be grams of nickel 2 chloride divided by 250 mils, right? Okay, and then I'll be done. Now, in order to get that, I've got to go from here to here. And that's what I'm looking for, right? That is here. Okay? So let's first of all, let's do this conversion here. And I'm a little bit busy. I'm a little bit busy here on space. So I'm going to disappear that and say, well, I need that. It looks like it's a 2-to-1 ratio. So what I'm going to do is I'm going to say, that's not what I want to do. I want to get rid of that. Yeah. Okay. So I want to take my moles of silver chloride, right? And I want to convert this to moles of nickel 2 chloride. Okay? And that's the way I'm going to do it. So I'm going to come back over here and find what my actual moles was. 4.265 times 10 to the negative 5. Negative 5. And I think this molar ratio was 2-to-1. Let me come back over here and verify. There's my 2, and here's my 1. That's right. So my molar ratio was 2-to-1. So it looks like I'm going to take that number divided by 2. Okay? Divide by 2 equals 2.128 times 10 to the 128 times 10 to the minus 5. Okay? So let's go back over here now. Let me get rid of that. And I'm going to put it here. You saw how I got that, right? I'm going to go back to that. 2.128 times 10 to the minus 5, right? Now, in order to get from that to mass, which is what I need here, go back here, right? I'm looking for mass. You see that? In order to get that, what I'm going to need the molar mass. So let's go to formula weight again. And it was nickel 2 chloride. So nickel is 58.693. Am I in the right layer? Yeah, 40. The formula weight of nickel 2 chloride is, I lost that. Just a second, let me come back here. It was 58.693. 58.693 plus 2 times chloride, which is 35.45, which is equal to, can't do that in my head, just a minute here, 58.693 plus, oh, just a minute here, 2 times 35, wait. 2 times 35.45 equals plus 58.693 equals 129.593. 129.593 grams per mole, right? Okay, now let me come over here. It's 129.593, okay? And that's grams per mole. So what I'm looking for is grams of nickel 2 chloride. So I've got grams of nickel 2 chloride per mole of nickel 2 chloride, right? And that's that number right there. And I also have moles of nickel 2 chloride. And look at that, I'm basically done. Okay? So this is 2.128 times 10 to the minus 5 moles of nickel 2 chloride times 129.593 per mole, right? So let me take those two numbers and multiply them, and I'll have my mass. 129.593 times, okay. 2.128 times 10 to the minus 5 times 129.593 equals 2.7577. Am I in black? I'm gonna go back to red. No, I'm in black. 2.7577 times 10 to the minus 3, right? So that's going to be in milligrams, 2.7577 in milligrams. So, got a phone call coming in, but I'm going to ignore it. I'll call them back. William, could you take that and just say I'm busy? Take another one, please. Thank you. So now I'm ready now for my final question. Calculate the concentration. So I have my mass. Let me write this in a different layer too. Let me go to this layer. And so this is going to be my final concentration. Let me go to blue. My mass of nickel 2 chloride per liter of solution, which is right, so it's going to be 2.7577 times 10 to the minus 3 grams of nickel 2 chloride divided by 0.250 liters of solution. Okay, now I'm going to get rid of this, and I'm going to let me disappear that. I'm going to rewrite this in a couple different, because that's a pretty clumsy number, right? 2.7577 times 10 to the minus 3 grams per 0.250 liters. Okay, And so what I'm going to do is, I don't have my calculator. I just gave it to my son. So I'm going to calculate this here with an Excel spreadsheet. Equals 2.7577 times 10 to the minus 3 divided by 0.250 equals 0.00. You see? Can you see that from where you're sitting? Can you see that? Is that too big on the screen? Too small? 0.01103. 1. Wait, cancel. And that's grams per liter, right? So we'll go back and look in a second to see how it's written, but it's probably given, oh, and this is not the right number of sig figs, so let's figure that out. So this is probably given though as 11.031 milligrams per liter, right? That's probably how it's given, but let's go back and look at the number of sig figs. I think we had, let me get rid of that, bring this back in. Okay, so we had 2 sig figs here. So let me come back here to this layer. Let's go to blue. This was 2 sig figs. This we looked up in a periodic table, and this was the product of those two, or the dividend of those two. So this is going to be 2 sig figs, right? This goes over here because we're divided by 2, so that's going to be 2 sig figs. And so that's going to be 2 sig figs, right? And because that we looked up in a periodic table. So now that we've got that, this is 2 sig figs, right? Oh, that's what we just did that a second ago. That's 2 sig figs. Okay, so let's go back now to this. That was 2 sig figs. That was 3. Okay, so our answer is going to be written in 2 sig figs. So this is either going to be 0.011 grams per liter, right, or 11 milligrams per liter. Okay, and Alex is probably going to have the unit in there with it for us. So let me go back here, and I go back here. It's going to take me a second to find it, but I do want to see that answer from their standpoint. It's going to be fun to see it. Solving for a reactant in solution, I think, was the question, right? So let's go here. Boom. Solving for reactant in solution. Still looking for it. It's going to take me a second to find it. Solving for reactant in solution. Honestly, I think that was early. Solving for reactant in solution. It's going to take me a minute to find this. You know what I'm going to do? I'm going to go to the student who asked me. I will ask her permission before I show this. This time and topic really is what I want. I will ask her permission before I put this on YouTube. I think that's the one right there.
Oh, can I go to...
I think, no, that's a different question. Let me go here. My wife just walked in. All right. Yeah, 11. There we go. 11 milligrams per liter. Okay. Very good. Very good. I hope that's helpful. A nice elaborate problem, but I guess the point is that I want to emphasize what we did was we set a table up and used these as my column headings and just went from and just calculated things as we needed them. we knew we needed moles to moles, and we had to identify what was meant by the concentration of nickel 2 chloride. And we did that by saying, right, this was our concentration. So we knew we had to find the grams of nickel 2 chloride and the liters of solution. All right, hope that's helpful.